Hi, good day to all. I am Vidya Padore from Group 2. Would like to introduce my group member who helped to complete this assignment 2 for subject BMMM 3583 Vibration Analysis and Monitoring. Me, myself, Vidya Padore. Second, Lukman Hakim bin Khairul Anwar. Third, Mahathir bin Hassan. Fourth, Muhammad Fadil bin Zulkifli. And fifth, Khairul Hakim bin Ahmad. Today, we are going to present our assignment 2 for vibration analysis and monitoring. This presentation video is about machine condition monitoring and fault diagnosis of shaft. Introduction. Approximate half of all operating costs in most processing and manufacturing operations can be attributed to maintenance. Machine condition monitoring and fault diagnosis can be defined as the field of technical activity in which selected physical parameters associated with machinery operation are observed for the purpose of determining machinery integrity. The goal in regard to maintenance activity is to schedule only what is needed at a time, which result in optimum use of resources. Condition monitoring of machinery is essential to prolong effective machine life, achieve the overall system reliability, minimize maintenance costs, and ensure consistent and desirable product.
I will talk about definition, machine condition monitoring and fault diagnosis. Firstly, condition monitoring is a key tool in predictive machine maintenance. With the collection and analysis of some signal from motor, it can be identified an unplanned downtime while preventing the development of defect and inefficiency. Secondly, condition monitoring, particularly vibration analysis of rotating machine, can predict and diagnose operational or structural defect. In rotating machinery, shaft misalignment and crack are common fault and they must be diagnosed before failure occur. This fault can be predicted with the help of other analysis. The effect of detecting fault with wireless sensor was also analyzed and different level of misalignment were detected and diagnosed with the help of force sensor. The force sensor is an encoder, accelerometer, laser vibrometer, and wireless sensor were used to conduct the comparison of the misalignment shaft. For example, the condition monitoring technique of the blade in turbo machinery were reviewed and vibration analysis were provided to be efficient for the detection of serve blade rubbing. In 1995, Seka and Prabhu discussed the effect of coupling misalignment on the vibration of rotating machinery. Shaft misalignment can be a significant cause of vibration due to reaction force generated in the shaft coupling. It is generally accepted that a significant 2x vibration response in a significant feature of bearing misalignment. From that, a finite element model of the rotor coupling bearing system was developed and the effect of misalignment was introduced through a coupling coordinate system.
Okay, hi, Assalamualaikum. My name is Mahathir bin Hassan. So today I will continue for this slide. So I will talk about the importance of machine condition monitoring and fault diagnosis. Okay, the first point is the important is it is to monitor the condition parameter on the machine. It will be in terms of vibration and temperature. Okay, the second point is to get useful information or data on the condition of equipment in a timely manner. Okay, the information is very useful to the operator, maintenance or engineers and technicians. because all the information will be discussed, and then they will maybe take some action to solve the problem. Okay, the next slide is the diagnosis involve recognizing the type of fault developing in different fault types may be more or less serious and require different action, and determining the severity of given fault once detected and diagnosed. The second point is to prognosis involve estimating, forecasting the expected time to failure, trending the condition of the equipment being monitored, and planning the appropriate maintenance timing. Okay. In the next slide, I will share about the advantages of machine condition monitoring and fault diagnosis. It will be increased machine availability and reliability. Next is improved operating efficiency, improved risk management. In other words, it is less downtime. Next is reducing maintenance costs. In other words, better planning. Next, reduce spare parts inventories, improve safety, improve knowledge of the machine condition, or in other words, save short-term overloading of the machine possible. Okay, next, extended operational life of machine. Next, improve customer relations, less planned or unplanned downtime. Next, elimination of chronic failure, root cause analysis and redesign. Next is reduction of post overhaul failure due to improperly performed maintenance or assembly. Okay, for the machine condition monitoring and fault diagnosis, intend to give more advantages rather than disadvantages. So it is advised to use this machine condition monitoring and fault diagnosis in the industry. So that's all. Thank you.
Okay, today I want to present about how to measure and diagnosis itself. For this slide, I want to explain about the relative vibration. Relative is measuring technique that refer to a certain point that is not silent. Then, relative vibration is a measurement of vibration, either displacement, speed, or acceleration. Measure relative to the position of the vibration sensor. Based on the diagram that show how the relative vibration and how the measurement is done by relative vibration. Okay, for this slide is about the absolute vibration. Absolute is a measuring technique that refers to a stationary point in free space. The absolute vibration is a measurement of vibration, either displacement, speed, or acceleration. Measure agents of stationary point in free space. Based on the diagram shows the absolute vibration and how the measurement are made. Now is about axial thrust position. This measurement of the rotor with the thrust bearing clearance. The measurement is usually made using two cross-made probe mount in the thrust bearing observing the thrust collar. If this is not practical, the probe may be mounted at some location close to the bearing, observing the shaft end, or specially fitted collar to ensure reliable measurement. Axial thrust position should always be made using two transducers. Now it's about the radial position. Radial position of the shaft reached in the bearing clearance can be measured using the DC signal installed from the crossmate probe. The DC signal is measured when the machine is at rest, with the shaft sitting at the bottom of the bearing, and again when the machine is running.
Conclusion. The benefit of vibration analysis is the different mechanical processes within the machine, for example, imbalance, misalignment, and shaft fault, will produce energy at different frequencies. The different frequencies are separate from one another through analyzer. Shaft components are subjected to difficult operating conditions in high-performance rotating equipment such as compressor, steam and gas turbine, generator, pump, and engines that are used in process and utility plant. Rotating machines are being designed to operate at high mechanical efficiency by decreasing the weight and dimension tolerance, leading to greater operating speed, power transfer, load, and stresses. As a consequence, many rotodynamic systems contain shafts that are susceptible to fatigue failure due to transfer and cross-sectional crack. The fracture shaft due to cracking is a rare event. However, if a crack in shaft is not detected and it bursts, the consequence lead to accident. This will affect personal safety, operating costs, and increase overall time interval and etc., which motivate to research in crack shaft detection. Vibration monitoring is one approach for detecting crack that will be implemented in an automated manner to help all avoid cost and safety issues.